Welcome back, dear students. So let's continue with what we were doing in the last class. So you know that we are dealing with exercise 2b. So today we are going to take question number 4 and I am taking sub number 1. So you need to simplify this. Okay, so observe this very carefully. Okay, now this is the given question. Now see here only this part. Okay, so I'm considering a to the power of 5 divided by a square, where we see the base are a, isn't it? So here in the numerator the power is 5 and in the denominator power is 2. Okay, so if you apply this law, look at this law carefully. If you apply this law in this, then you get a to the power 5 minus 2. That is a to the power m minus n. Okay, now if you observe the same with this one, this b square by b cube, so this can be taken up and this minus 3 becomes plus 3. Okay, using the very same law again. Okay, now a to the power 5 minus 2 is how much? It is 3. Now 2 plus 3 is 5. So that's why your answer for this one turns out to be a cube into b to the power 5. Okay, so that is pretty simple, isn't it? Now let's take this problem. So I am taking question number 4, sub number 4. Okay, so you need to simplify this. Okay, so if you see here, can I write this divided by in this way? Yes, definitely we can write in this way. Now this 5 and 15. Okay, so don't worry about this. Let's see what happens here. Okay, now if you observe this one, okay, so b square by b to the power minus 3 is going to be the same here. Okay, so basically when you make use of this law, this minus 11 goes up and becomes plus 11. Okay, so that's why it is 16 plus 11. Now we have 5 by 15 and you know 5 and 15 can be cancelled by 5. So you get 5 ones are 5, 5 3s are 15. So that's why this 5 by 15 is nothing but 1 by 3. Okay, and 16 plus 11 is how much? 27. So that's why your answer turns out to be this much for this case. So you may pause the video and note down the solution. Okay, so let's take sub number 6 from question number 4. So you need to simplify this. Okay, so if you see here, this 1 by 3 power is there, no? Using this law, this power n is for both, that is a and b. So that's why it is a to the power n, b to the power n. I'm going to do the same here. Okay, so I'm writing 125 to the power 1 by 3 into x to the power minus 3 whole to the power 1 by 3. Okay, now see, can I write 125 as 5 cube? First factorize 125, you get 5 into 5 into 5, which is actually 5 cube. Okay, now in this, why am I getting minus 1? Because I am applying this law. See, this law says that you need to multiply the powers. So when you multiply minus 3 and 1 by 3, 3 and 3 gets cancelled, so only minus 1 will be left. Now again I am going to apply the same law here. Okay, so 3 and 1 by 3 will get multiplied, so 3 and 3 gets cancelled, so ultimately you get 5 to the power 1, and x to the power minus 1 can be written as 1 by x as per this law. Okay, so as I said, this is 5 to the power 1. So how much is 5 to the power 1? It is 5, isn't it? So this is 5 into 1 by x. So how much is this? 5 into 1 is 5. So that's why your answer for this will be 5 by x. So you may pause the video and note down the solution. Okay, let's have a look at sub number 9. Okay, so as you know, as per this, I can write this power 6 for each of them, that is minus 2 to the power 6, x to the power 2 by 3 whole to the power 6, and y to the power minus 3 by 2 whole to the power 6. Now one thing that you need to remember is minus, the even power of negative is always positive. I have already told you about this, and if it is odd, then this negative will remain negative itself. So that's why in the next step, if you see, I have not written minus, because the even power of negative is always positive. So that's why this negative became positive here. Now here again apply this third law. So multiply the powers, and similarly here also you will multiply the powers. So 3 1s are 3, 3 2s are 6, so 2 into 2 is 4. That means the power of x becomes 4, and in this case 2 and 6 gets cancelled 3 times, so 3 into 3 is 9. So that means the power of y becomes minus 9, okay, and 2 to the power 6, that means if you multiply 2 6 times you will get 64. 2 into 2 into 2 into 2 into 2 into 2. So if you do that you will get 64, and as I said, this power is, the power of x is 4 and the power of y is minus 9. Again, for y to the power minus 9, if I apply this law, this y to the power minus 9 becomes 1 by y to the power 9. That is, your answer becomes this much. Okay, so you may pause the video and note down the solution. So let's have a look at this question. So before doing this, I want to say that question number 8 from the same exercise is exactly the same as this. Okay, now if you see here, in every term, okay, in every term we have got one power outside, isn't it? So there we'll make use of this law, because we have got one extra power from outside. So as per this law, we need to multiply the powers. So if you multiply the powers, you get a plus b into a minus b, b plus c into b minus c, c plus a into c minus a. So that's what is done here. Now we have direct formula for this. All of you know that a plus b into a minus b is a square minus b square. Similarly, b plus c into b minus c will be b square minus c square, and c plus a into c minus a will be c square minus a square. So that's what is written here. Now if you apply this law, see, for all these numbers base is x, isn't it? So base is same. So if the base is same, for example here we have a to the power m into a to the power n. So whenever bases are same, then we need to add the powers. So we'll add the powers. So you get a square minus b square plus b square minus c square, okay, plus c square minus a square. Okay, now see here carefully, a square minus a square, they gets cancelled, minus b square plus b square also gets cancelled, minus c square plus c square, they will also get cancelled. So everything is vanishing, means how much is left? We have only 0. So that's why this is x to the power 0, and we know that x to the power 0 is always 1, isn't it? So that's why your answer is 1 in this case. And in your question number 8, you are asked to prove that this is equal to, this entire thing turns out to be equal to 1. So both means the same. Okay, so you may pause the video and note down the solution. Okay, so let's have a look at this now. So this is the given question. Now if you observe this part only, okay, I am talking about only this part, this is similar to this, isn't it? Okay, so this n here is 5, okay, so this n goes to the denominator of this power m, okay, so that's what I am going to do here. Okay, so this is actually to the power 1 by 5. Okay, so for this entire thing together, see here carefully, for this entire thing together I am taking the power to be 1. Okay, so because we know that anything to the power 1 will be that number itself, so that's why I have written 1 here, and this 5 goes to the denominator of the power. Okay, now again if I apply this law, this 1 by 5 power is for everyone, that is x to the power 20, y to the power minus 10, z to the power 5, and you know that this powers will in fact get multiplied. So x to the power 20 whole to the power 1 by 5 is there, no? So that's why 20 and 1 by 5 they'll get multiplied. Similarly, minus 10 into 1 by 5 and 5 into 1 by 5, that's what you get. Now do the cancellation. 5 1s are 5, 5 4s are 20, 5 1s are 5, 5 2s are 10, 5 1s are 5, 5 1s are 5. Okay, now I'm converting this division into multiplication, and if I do that, then this will turn upside down. So this y cube comes to the numerator and this x cube go to the denominator. Now we know that this is x to the power 4, yes, this is x to the power minus 2, and this is z to the power 1. Okay, now x to the power 4 divided by x cube, apply this law, so you get m minus n, that is 4 minus 3. Similarly, we have minus 2 into y cube. Okay, so apply this law, you need to add the powers, so you get minus 2 plus 3. And for z, we don't have any pair, so z will remain alone. Okay, so we get this much. So x, as I said, you get this x cube goes up, becomes 4 minus 3, and minus 2 is there, so you have to add plus 3. Okay, so 4 minus 1 is, I'm sorry, 4 minus 3 is 1. Minus 2 plus 3 is also 1, so z to the power 1 is, or z to the power 1 itself. And we know that x to the power 1 is x, y to the power 1 is y, z to the power 1 is also z. So that's why your answer turns out to be x, y, z for this. So you may pause the video and note down the solution. Okay, so here I have got few homework for you. So you will do this homework and send me the same. Thank you very much.